Let us look at asymptotes of a curve. A line y is equal to mx plus c, or x equal to a, or y equal to L is an asymptote of a curve y is equal to f of x if the distance between the curve and the line tends to 0 as x goes to infinity, goes to minus infinity, or x goes to a from the plus side or from the minus side. Now here, this is a line y equal to mx plus c which has a slope. X equal to a means it's a vertical line. Y equal to L means it is a horizontal line. So here, this is a slanted or an oblique asymptote. This is a vertical asymptote, and this is a horizontal asymptote. Let's see with an example. Let's say I have a function 1 by x minus 2 plus 2. If I plot it, I'll get this. And if we take a point on this, as I go towards plus infinity, what happens? It gets closer and closer to some value of y. Similarly, if I go towards minus infinity, it goes or it tends to some value of y. And similarly, when I come towards some specific value, it goes to y goes to minus infinity or it goes to plus infinity. Yes. So we need to figure out what are those lines. So here it is pretty straightforward. We know that the denominator cannot be 0. So x minus 2 cannot be 0. That means x cannot be equal to 2. So that means x equal to 2 is going to be an asymptote, whether we come to 2 from the positive side or the negative side. Similarly, on this side, y equal to 2 is an asymptote of this curve. So the asymptotes are y equal to 2 and x equal to 2. Okay, let's take another example. Let's take this curve. This is x square plus 2 divided by x minus 1. Here the asymptotes are y is equal to x plus 1 and x equal to 1. These are the two asymptotes. One is a vertical asymptote and the other is an oblique asymptote. So here asymptotes are y equal to x plus 1 and x equal to 1. Now if the asymptote is parallel to the x-axis, we say horizontal asymptote. If it is parallel to the y-axis, vertical asymptote. And if neither, then we call it as an oblique or slant asymptote. Let us look at another curve and see how step by step we can arrive at these asymptotes. So this is an equation. X squared times y square is equal to a squared times x square plus y square. Now we take the coefficient of the highest power of x. Highest power of x is 2. So we take the coefficients of x square. So that is what? It is y square equal to a square. So we have y square equal to a square, which means y is equal to plus or minus a. So that means y equal to 2 is an asymptote. Y is equal to minus 2 is an asymptote. By the way, for this particular graph, I have kept a as 2. And now what we do is we take the coefficients of the highest power of y. That is x square is equal to a square, which means x is equal to plus or minus a. So which means x equal to 2 is an asymptote. X equal to minus 2 is an asymptote. So now let's take another example in polar form. So the curve that I have is r is equal to a theta divided by theta minus 1. And if we plot it, we get this. Okay. Now the first thing we do is we write it in a particular form, in the form of f theta is equal to 1 by r. So if that is what we are going to do, then we have f theta is equal to 1 by r, which is equal to theta minus 1 by a theta. Now this function would be 0 for some value of theta. So let's say that particular angle is alpha. So f alpha equal to 0 implies alpha minus 1 by a alpha is equal to 0, which implies alpha minus 1 equal to 0, which implies alpha equal to 1. So here, what do we have? We have the fact that angle, when it is equal to 1, r blows up, will blow up when f theta equal to 0. Look at it, think of it like, cross multiplying it. We will end up with r is equal to 1 by f theta. So f theta is equal to 0 means r goes to infinity. So that is how we say r blows up at an angle alpha equal to 1. Let's go back to f theta is equal to theta minus 1 by a theta, and let's break it up into theta by a theta, which gives us 1 by a minus 1 by a theta. Now let's differentiate this to get the slope. So f prime of theta is equal to 1 by a is a constant minus the derivative of 1 by a theta is minus 1 by a theta square. So minus minus cancels out. We get 1 by a theta square as the slope of the tangent at angle theta. But we are interested in the slope of the tangent when theta equal to alpha, that is 1. So f prime of alpha equal to 1 by a. How did we get 1 by a? Because here we are substituting theta by alpha, which is 1. So here it becomes 1 by a alpha square. So we end up with 1 by a. Using the equation of a line in polar form, we have r times sine theta minus alpha is equal to 1 by f prime of alpha. That becomes r times sine theta minus 1 equal to a. How did we arrive at this? Because 1 by f prime of alpha is equal to a. And here we are substituting alpha with 1. And if I plot this, we get a straight line which will be the asymptote. So here, if you notice, as x goes to infinity, the curve tends to get closer and closer to the asymptote without actually touching it. Similarly, as x goes to minus infinity, the curve gets closer and closer to it without actually touching it. That was asymptotes of a curve. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.